to characterize the phenotype of the cells presented in osteoarthritic cartilage and also to investigate their cartilage repair potential. What is osteoarthritis? Osteoarthritis is a degenerative joint disease which affecting the whole joint, but actually is the mostly presented by degradation and a loss of the cartilage. Now I'm going to show you the video, what I have here.
Over time, causing a narrowing of the joint space. When this shock absorption
On
is
the
lost,
video, I hope you can see that actually over time cartilage is lost, and when the cartilage is completely lost, bone can rub against bone, what causes pain, stiffness, and disability of the patient. And here on, after this video on radiology, what will be shown now, you will see the difference between the normal knee and osteoarthritic knee. And in osteoarthritic knee, you see that whole joint is actually deformated. And then on the one part that we have a complete loss of the cartilage. On the next slide, I have arthroscopy of the healthy knee and osteoarthritic knee. Do not switch now. Again, on the video, I will try to explain you without the video. Actually, what is arthroscopy? Arthroscopy is a common surgical procedure where we use the little camera to see inside of the joint, and it's used for the diagnosis and a treatment of different knee problems. And when you make arthroscopy of the healthy knee, you can see that the surface of the cartilage is actually really regular and smooth. But when you are making arthroscopy of the osteoarthritic knee, you can see that all of the surface is actually irregulated and fibrillated. And unfortunately, no, it doesn't work. But on this video, you will see, I can show you after, you will see that one big part of the cartilage on weight-bearing area is completely lost. Today we have many different arthritis, but now I'm going to present you like the last one, and this is named autologous chondrocyte transplantation. Autologous chondrocyte transplantation is actually based on the biopsy of the preserved of the normal cartilage from osteoarthritic joint. As you know, when osteoarthritis affects the joint, it doesn't affect completely whole the joint. Some of the little areas, mostly no weight-bearing areas, stayed. What they do, they isolate this tissue. Then from that tissue, they make isolation of the chondrocytes, what are specific cell type for the cartilage. They proliferate cell culture, and then they inject them back in a damaged area of the cartilage. Then it's autologous, it's in the same patient. However, this method has two major side effects. The first one, on this repair seat, over time, we start to have calcified cartilage. And calcified cartilage doesn't have the same biomechanical characteristics like a normal cartilage. For example, it has a much lower shock absorption potential than the normal cartilage. The second major side effect is once when you touch the cartilage, even the preserved part from osteoarthritic knee, you will cause damage. Why? Because cartilage doesn't have a self-repair potential. And this damage can actually lead to secondary osteoarthritis on that seat as well. As the treatments to date didn't give us desirable results, now scientists, and including me, we are searching for alternative method for the cartilage repair. And one of the most promising today is the repair by mesenchymal stem cells. Mesenchymal stem cells are multipotent, and they can be differentiated in a variety of cell lineages. As you can see here, they can be isolated from the many other tissues as a bone marrow, synovium tissue, fat. And if we put these cells in vitro under permissive conditions, we can form specialized tissue as adipocyte, bone, and also cartilage, what is actually our target of interest. Based on the fact that this kind of cells can be isolated from a different adult tissue, our hypothesis is that we can find dead cells also in a damaged area of osteoarthritic cartilage, that we can isolate cells, and by proliferation and cell culture, we can use them to regenerate healthy cartilage. What is the advantage of this? Advantage of this is that we will use completely damaged areas of the cartilage, what will otherwise will be wasted, will be literally put in a garbage. So we have three main objectives. The first one, as I already mentioned, is to characterize the phenotype of these cells. The second one is to see, can we proliferate these cells? Are they viable? And the third one is to try to form cartilage healthy cartilage from these cells. To do that, we are using the osteoarthritic tibial plateau, obtained after the total knee replacement. And first, what we do is microscopical grading. Actually, we divide tibial plateau on a different grades of degradation. As you can see here, the grade 1 actually presents the most preserved, the most normal cartilage. While if you take example of the grade 2, it's the last stage of osteoarthritis where there is almost no cartilage left, and we have exposure of the subchondral bone. Then each of these parts we divide on three further parts. One part we use for histology, the second part we use for the isolation of the tissue and analysis of the tissue, and the third part we use for isolation of the cells and analysis of the cells. To explain this further, part for histology, after histological procedure, we are staining histological samples by saffronin O to see distribution of the cells and composition of the cartilage matrix. And then to establish the total histological score, we are actually using ICRS scoring, what is the standard to grade to score the osteoarthritis samples. Cartilage. As you can see, this is based on the scale from the grade 0 to the grade 5, where grade 0 presents the intact normal cartilage. While we go further, we have degradation, more and more degradation of the osteoarthritic cartilage. As you can see here in grade 1 and grade 2, we have a loss of staining, what means depletion of the cartilage matrix. We have irregulated surface of the cartilage, and in a grade 3 and 4 we have a fissuring of the tissue and also loss of the staining, and like in the last stage we have just a little bit of cartilage left and exposure of the subchondral bone. The second part, as I said, we use for isolation of the tissue, and what we do, we are measuring the markers of two specific cell types, chondrocytes and mesenchymal stem cells. Chondrocytes because these are typical cell type for cartilage, and we are expecting to find this in our osteoarthritic cartilage. And to confirm our hypothesis, we are measuring the markers of mesenchymal stem cells. And the third part we use for isolation of the cells, we proliferate the dead cells. Then after proliferation assay, we again measure markers for chondrocytes and mesenchymal stem cells to see differences between before proliferation and after proliferation, but also one part of the cells we are using for chondrogenesis. Actually, we are putting dead cells in a medium which stimulates the differentiation of the cells to the chondrocytes, and we are observing, are we able to form cartilage? Now I'm going to present you our preliminary results. This had been made on the 10 samples, on the 10 tibial plateaus, and the results of histology showed that actually the 4 of the samples correspond to the grade 0 and 1, that 6 of the samples correspond to the grade 2 and 3, and the 3 of the samples correspond to the grade 4. the results on the osteoarthritic tissue, these are cells isolated from the last osteoarthritis from the grade 4, and we can see that in the cells, it has been made by immunofluorescence. We have expression of the nucleostemine, what is a marker of mesenchymal stem cells, in the nucleus of the cells which presented in blue. Also, by qPCR, we showed that we have expression of endoglin, what is the second marker of mesenchymal stem cells, in all the grades from osteoarthritic cartilage, from the preserved part of the cartilage, but also from the last stage of osteoarthritis. Based on these two results, we can confirm that we have at least two cell types presented in osteoarthritic cartilage. Chondrocytes, actually here, I can show you that we also show the expression of the chondrocytes markers, collagen 2, and by qPCR, we showed the expression of the collagen 2 and aggregain in all of the grades. Then based on these two results, we can say that we have at least two cell types, chondrocytes, what we were expecting, but also these results indicated presence of mesenchymal stem cells in osteoarthritic areas. Now when we know this, we wanted to see, are these cells viable and can they proliferate in a cell culture? And if you take a look of these results, we show that in all of the grades of osteoarthritic cartilage, we have an increase of the cell number after the proliferation of just 10 days compared to the cells just after isolation. And then based on this, we are able to say that yes, they are viable and we can proliferate them and increase the number of the cells in a cell culture. And then after, we wanted to see which kind of cells we have after proliferation. And if you take a look of the markers of chondrocytes, you can see that collagen 2 as well as aggregain are decreasing after the proliferation step compared to the level in the cells just after isolation. While if you take a look of endoglin, marker of mesenchymal stem cells, you can see increase of this marker after proliferation compared to the isolation. And based on this, we can say that the total number of mesenchymal stem cells actually increase after proliferation, while the chondrocytes decrease. And then in the end, we want to see, can they form the cartilage tissue? And here I'm going to show you that after 2 weeks of differentiation assay, we were able, from these cells, from proliferated cells, we were able to form cartilage tissue. And also, by 2 specific stainings, we showed that we have formation of the cartilage matrix. With hematoxylin eosin staining, we show formation of the proteoglycan, what is one of the main components of the cartilage matrix. And with Masson trichrome staining, we showed the formation of another major component of the cartilage matrix, collagen 2. Taken together, we may say that we have viable cells in osteoarthritic cartilage, in damaged area of osteoarthritic cartilage, that these cells have proliferation potential, that these cells correspond to the chondrocytes and also mesenchymal stem cells, that after proliferation we have more mesenchymal stem cells, and that these cells, after 3 weeks of differentiation, were able to form cartilage tissue and the cartilage matrix. My further perspectives are first to increase the number of the samples. As you see, I'm working on human samples, and it's a little bit hard to work on human samples and at least to obtain the human samples. Then after, by flow cytometry, I want to confirm expression of more specific markers of mesenchymal stem cells. And also, I will try to differentiate that cells to the osteocytes and adipocytes lineage to confirm further that I really have these kind of cells in my osteoarthritic cartilage, as this is one of characteristics of mesenchymal stem cells, that you can push them to differentiate to different cell lineages. In the end, I want to thank to the whole team of my lab, especially to Professor Eshmi Tumi, who's supposed to be here with us, but unfortunately he didn't come. Also to our collaborators, the hospital in Lille and hospital in Orléans, France, and to the Institute of Prevention and Research of Osteoporosis. And thank you very much for your attention.